Assalamualaikum and hi everyone. In this video, we're going to solve example 3 where we need to produce the system transfer function using the block diagram simplification method. Before we solve the example, let's see some additional tips in using block diagram simplification method. So the first step in block diagram simplification method is to analyze the block diagram, where in this step, we need to locate for any series block, feed-forward parallel block, or feedback parallel block. If we found any of these blocks in the block diagram, then we're going to simplify it. However, if the blocks cannot be simplified due to the position of summation point or peak-off point, then the summation point or the peak-off point need to be moved. For tips number 3, please understand that summation point or peak-off point can only be moved over a block. Therefore, in diagram 1, summation point can be moved over a block toward the output. However, in the second diagram, the summation point cannot be moved over the block toward the output because there is an additional peak-off point there. It means summation point cannot be moved over a peak-off point than over a block. Tips number 4, please make sure that you will be able to simplify any of series, feed-forward or feedback parallel block after you have moved the summation or peak-off point. If you cannot simplify that, then don't move the summation point of the peak-off point. So now let's solve example 3. First step is to analyze the block diagram. So looking at this block diagram, we can see that there are two feedback loops in this block diagram. This is the first feedback loop, and this one is the second feedback loop. Let's try to simplify these feedback loops. Can we simplify feedback loop number 1? Yes, we cannot simplify that. Can we simplify feedback loop number 2? Yes, we also cannot simplify that. What is the reason why we cannot simplify the feedback loops? Yes, this is due to the position of this summation point in the feedback loops number 1. That's why we cannot simplify feedback loops number 1. As for feedback loops number 2, it is due to the position of this peak-off point. So that's why we cannot simplify the feedback loops number 2. Therefore, we need to move either the summation point or the peak-off point so that we will be able to simplify the feedback loops. There are two options to move the peak-off point or the summation point. For the peak-off point, we can only move the peak-off point over G2 toward the output. But we cannot move the peak-off point over G1 toward the input due to the summation point here. Similarly, we can only move the summation point over G1 toward the input, but we cannot move the summation point over G2 toward the output. So in this example, I choose to move the peak-off point toward the output. So after we move the peak-off point toward the output, the block diagram will look like this. So you can see there is additional block which is 1 over G because we have moved the peak-off point over block G2. So after we have moved the peak-off point, now we can solve for these feedback loops, and also we can solve for this series block. After we simplify the feedback loops and the series block, the transfer function will become H2 over G2 for the series block and G2 over 1 plus G2H1 for the feedback loops. Now, for the last step, we need to simplify the final feedback loops. So we are using the equation G over 1 plus GH. Notice that the sign here is negative. Therefore, in our equation, it will be positive. So we can write that G is G1, G2 over 1 plus G2, H1 divided by 1 plus G is G1, G2 over 1 plus G2, H1 multiply with H, which is H2 over G2. So here we can cancel G2 and G2. Then we multiply this with 1 here. So we get G1, G2 over 1 plus G2, H1 divided by 1 plus G2, H1 plus G1, H2 divided by 1 plus G2, H1. So now we can cancel the denominator, and the final transfer function will be G2, and the final transfer function will be G1, G2 over 1 plus G2, H1 plus G1, H2. So this is our final transfer function, which relates between the input R and the output C. So we get this final transfer function using the block simplification method.